Hello, Matt here from ChemistryStudent.com. In this video, we're going to look at electronegativity. We're going to talk about what electronegativity actually is, why differences in electronegativities between two atoms lead to polar bonds, and how electronegativity changes across a period and down a group in the periodic table. Before we talk in detail about electronegativity, there are a few essential ideas you need to be comfortable with. Covalent bonds are atomic bonds that form when two atoms share a pair of electrons. An atomic orbital from each atom overlaps and creates a new area of electron density between the two atoms. The positively charged nucleus of each atom is attracted to the shared electron density, and this pulls the nuclei closer together, creating a covalent bond. Inside a single bond, there is one pair of electrons. Atomic radius decreases across a period in the periodic table. This is because all elements in a period have the same number of inner electron shells and have the same level of inner electron shielding. All their outer electrons are in the same shell. As the number of protons in the nucleus increases across a period, the positive charge from the nucleus also increases. So this means the outer electrons experience a greater attraction to it and are pulled in tighter as a result, decreasing the size of the atom. Atomic radius increases down a group in the periodic table. This is because the number of inner electron shells increases, meaning the outermost electrons get further away from the nucleus, and this increases the size of the atom. Recap done, let's go! In a covalent bond, the pair of electrons shared between atoms isn't always equally shared. Sometimes one atom will pull the electrons towards itself more than the other, leading to an unequal distribution of electron density and the creation of a dipole moment or polar bond. The bond is described as being polar as it has a positive end and a negative end. Electrons are negatively charged, and the atom with more electron density around it will have a partial negative charge, and the atom with less electron density a partial positive charge. Partial charges are just that, partial. It's almost like saying the atom is a little bit negatively or positively charged. It is important to note, though, that both electrons are still shared between the atoms. There is still a covalent bond. It is just that at any one moment in time, you are more likely to find the electrons closer to one atom than the other. How much an element can pull the electrons in a covalent bond towards itself is referred to as its electronegativity. Atoms of elements with a high electronegativity really want the electrons in a covalent bond to be around them, and they pull the electrons slightly towards themselves. Atoms of elements with a low electronegativity don't really care about having the electron density around them, and they don't pull the electrons towards themselves. The absolutely key thing to understand here is that electronegativity is relative. That means it is only ever the difference in electronegativity between two bonded atoms that matters. It's a bit like two people in a tug-of-war competition. It doesn't really matter how strong one person is, it's how strong they are compared to the other person. Electronegativity is the same. If you have a very strong person pulling against a weaker person, then obviously the rope will just get pulled towards a stronger person. Just like the electrons in a covalent bond being pulled towards an atom with a higher electronegativity compared to the atom with a low electronegativity. However, if you took the same strong person as before and now put them against someone who is even stronger than them, the rope will get pulled in the opposite direction and away from them. Just like if you replace the other atom in a covalent bond for an atom with a higher electronegativity, the electrons will now get pulled the other way. Relative things are always tricky to work with in chemistry. To help with electronegativity, we use a scale called the Pauling scale of electronegativity. At this level, all you really need to know here is that we describe the relative electronegativity of an element with a number. The most electronegative element, fluorine, has a value of 4.0, and the least electronegative element, francium, 0.7. Everything else is in between. In short, high number means high electronegativity, and low number means low electronegativity. When two atoms are bonded together, how polar the bond is will be determined by the differences in their electronegativities. For example, hydrogen has a very low electronegativity of 2.2, and fluorine, we've already said, 4.0. This would mean a difference of 1.8, given a very polar bond. If we were to take hydrogen and bond it to chlorine though, the difference would be 0.94, as the Pauling value for chlorine is 3.16. This means the electrons in the HF bond are pulled more towards the F than towards the Cl in the HCl bond, giving a more polar bond. If two identical atoms are bonded together, the bond will be nonpolar, as both atoms will be trying to pull the electron density by the same amount, like a tug-of-war competition between two people with equal strength. It is possible to predict the electronegativity of an element based on its position in the periodic table. Electronegativity increases across a period and decreases down a group. This is because the smaller the atomic radius and the larger the positive charge of the nucleus, the easier it is for an atom to attract the negatively charged electrons in a bond towards themselves. As you move across a period, the amount of inner electron shielding remains the same for each atom, and yet the nuclear charge increases, meaning a smaller atomic radius due to increased attraction between the nucleus and outer electrons. This means it is easier to attract new electrons towards the atom. If these atoms are covalently bonded to another atom, they are able to pull the bonding electrons slightly towards themselves. This is why electronegativity increases across a period. The opposite is true as you go down a group. Inner electron shielding increases as there are more inner electron shells due to the atom getting larger. This means the outer electrons in the surface of the atom experience less attraction to the nucleus, making it harder for the atom to attract the electrons in the bond towards themselves. This is why electronegativity decreases down a group. We've seen so far that if two atoms of different electronegativities are covalently bonded together, the bond will become polar. The more electronegative atom will get a partial negative charge, and the atom with the lower electronegativity will get a partial positive charge. If the difference in electronegativity is high enough, the covalent bond will effectively become ionic. As so much of the electron density will be around one of the atoms, it will basically become negatively charged and the other atom positively charged. Now the atoms remain close together due to attraction between their opposite charges rather than the sharing of electrons in a covalent bond. For this to happen, the difference in electronegativity values for the two bonded atoms, based on the Pauling scale, needs to be greater than 2.0. For example, sodium has an electronegativity value of 0.93, and chlorine has an electronegativity value of 3.16. The difference in electronegativity between the two is 2.23, meaning an ionic bond will always form. In reality, most bonding lies somewhere between covalent and ionic, with ionic and covalent character describing how much a covalent bond is like an ionic bond and how much an ionic bond is like a covalent bond. This is usually for more advanced study in the course and is beyond the scope of this video. It has been outlined in more detail at chemistrystudent.com. So, to summarise, electronegativity is the ability or tendency of an atom to attract a pair of electrons towards itself in a covalent bond. Electronegativity is a relative term, and the Pauling scale is used to compare electronegativities for different elements. Atoms of elements with a higher electronegativity than the atom they are covalently bonded to can pull the electron pair towards themselves slightly. This gives the atom a partial negative charge and the other atom in the bond a partial positive charge. The bond is described as being polar as it has a positive end and a negative end. The size of the polarity in partial charges is based on the difference in electronegativity between the two bonded atoms. The larger the difference in electronegativity values, the more polar the bond. Electronegativity increases for elements as you go across a period in the periodic table and decreases as you go down a group in the periodic table. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.